How you doing guys? Bioinformatics guy here with another video of the series Bash Essentials for Bioinformatics. In this video we will be talking about the power of pipes. Before we dive into that, we will take a look at different building blocks, and then we will see what is meant by pipes. Before we see how that works, I will tell you basically what does mean by pipe. So pipe is something when you can give the output for one command to the next command. It's kind of like piping the output into different commands that we have to do. So by using pipes you can create pipelines. So without a further ado, let's get started. So initially we will start with the building block. So I will tell you about this WC command. This is the command to count. So we will count in this tiny compressed file. We will run WC and we will see what we get. We get this 166 944 45009. Now the thing is that we don't know what is this, and this could be a bit confusing because if you are not sure what these numbers are, then it could be a bit confusing. Right now I can tell you that this 166 is the number of lines, 940 is the number of words, and this 45009 is the number of characters. So rather than using just WC, if you wanna just see the number of lines, you can use -L. L stand for lines, so you can use this flag if you just wanna see the number of lines. So now you see just 166 over here. If you wanna see the number of words, you can type -W. You got 940. If you wanna see the number of characters, you will type -C. And you got 45009. So I will clear up the space and I will then tell you about the wildcard. This wildcard we have already used is this star symbol. So this wildcard helps you to work on multiple files together. Do you remember that we used cat command on testing? Let's see what happens when we run this with the star command. You see, now we are able to see the contents of that file, of all the testing files. Similarly, we can count the number of lines in all the TSV files. So let's see how that works. Right now we are using this wildcard at the end of the name. We can also use at the beginning. Then we will not care about the suffix or the beginning of the file. Let's clear up the space. And then we will use WC -L. And now we want to take a look at the number of lines in all the TSV files. So we have written our wildcard and then we will give the extension of the file. And if I hit enter, I'm seeing that these two files contain the same number of lines, this labels file as well. And it also tells us the total number of the lines in all the files. So you can try this word count on different files. You can try it on this FAI file. Then you can also try this on TXT files. You see this hello contains 3 lines, these testing contain 1 line. You can also try this on the reference file, and you see that there are a lot of number of lines in this file. Let me clear up some space and then we will take a look at how to decompress file, and for that we will use this command gun zip. We can use this gun zip command on any file, but if you will just use it like that, it will replace the original file. So let's first make a copy of a file, and we can r1 underscore copy underscore fastq.gz. If we do ls, we have this copy now, and let's try to unzip this. We will use gun zip, and then we will use tiny r1 copy. If we hit enter and try ls again, we see that our copy is not the compressed file, it is rather just fastq. So one mistake that we made over here was that we forget the copy, the dot. While copy, there should be a dot over here. So let's do this again. We will remove this tiny r1 copy. We will do ls to see if it's gone, and let's copy again. We will use the up arrow key to get the previous things, so we will use this dot over here. It does not make a much difference, but it's easier to see with the dot. So we are making a copy again, and let's try this gun zip on this thing. But before that, let's use this ls command to see if we have the copy. So now we have the copy. So if we will run gun zip on this file, this last extension we will be gone, and we will be ending up with this fastq file. Let's try this gunzip gun zip tiny r1 copy.fastq.gz. If I do ls again, now you see that this file is gone, and now we have this file tiny copy.fastq. So this is one way to decompress the file. Let's see that we do not want to create the file, we do not want to lose the original file. We just want to see the contents of the file. So you can use this gun zip, and then you can use this -c flag, and this -c flag will uncompress the file and put the contents of the file on the standard output. So let's try this on this tiny compressed file. If I hit enter, I will now see all the content of this file. So this is one good way to get all the contents of the file on the screen. I will clear up the screen now, and before we move on to using pipes, let's see how we can recompress the file. We can use gzip, and then we can type the name of the file. We will recompress this copy, and let's do ls again, and now we can see that the copy is compressed again, and our original file is gone. We can remove this file, and of course you can use it with the with our wildcard approach. If you wanna do gunzip star dot gz, this command is gonna uncompress all the files, and then you can you can compress it again by using the gzip command. Yeah, let's just not do that at the moment. There are few different flags that you can use. You can use minus, and then you can write the number 1 to 9 to get the fastest or the most compressed version. 9 is gonna be doing best compression, smaller file sizes, and 1 is gonna give you a really quick compression. Before we move on to pipe, so we can do WC to count, and then we can count the number of the lines. Then we can use this wildcard, and we will be counting the number of lines in all the FASTQ files, and we will direct the output to lengths file. Okay, so we have tried it on the compressed files over here this time, and then we can try the sort minus n and on lengths, and you see that this time it is sorting the contents of the length file again. Let's see the magic of pipes. So here is the thing. So you have seen that we have created the length file, and then we were able to sort that file. And the thing is that if we want to see the output of the sorted file directly in one step, that's a bit difficult to do, because first we have to create the length file, and then we are sorting it. So you know what, we can do this in one command. What if I want to see the sorted lengths on the TSV file? So we will start with WC minus L, and we will see TSV over here, and let's see what we get. So we got the same result. So I guess this TSV is not a good option. So let's start on the FASTA files. So yeah, so we have this sample.fasta, we have reference.fasta, we have sequence.fasta. We have 3 FASTA files in our folder, and let's see if we wanna, right now since it's not sorted, if we wanna see the sorted, we can use the pipe, and then we will use our sort tool, and then we will give it minus n. Voila. Now you are able to see the sorted output, and this time we didn't even have to create this length file. So this is a really cool way to pipe your output to a different command. So that's all for this video. Please give it a try for that long pipeline, and you can also try different things to create your own small pipelines, which are just gonna be one line pipelines in your terminal to do different things and to do different checks on different files. And in the next video we will be talking about that small grep tool, which is really cool to manage different files. Thanks again for watching. If you have any questions, feel free to leave them down below, and feel free to leave some comments down below if something was confusing or if you really like something. Thanks again for watching. See you around in the next video.